Okay, so we're shifting gears. The one big thing that's going to happen with this shift is your workload is going to increase quite a bit. On average, it's going to take you about 8 hours a week to do the labs going forward for the next 8 weeks. So just don't try doing the labs on Sunday. You're going to need a lot more time than that. Part of it is a lot of the time you're waiting for things to build. So it's not so much a heads down, breaking your brain for 8 hours. It's a you kick something off and 15 minutes later it finishes, then you kick off the next thing. So which is classic what happens when you're building Windows servers. There's certain things you're going to be able to multitask, other things you won't be able to multitask. So I'm going to try and give you pointers about where you can save time, where you can multitask on various things. But there's a lot that we're going to be doing. I try and make it as efficient as possible for you as you're going along, but there are times that you are going to have to take the whole environment you've built, except for your gateway server, and build it again. Because we basically burn it to the ground other than the gateway, we rebuild it, and then right before the practical exam at the end, we burn it to the ground and rebuild it again for the practical exam. So this week, 2 labs, SQL 2019 on Linux and SQL 2019 on Linux Lab 2. In order to do those 2 labs, actually, I need to get the lab document up. That will make things a little easier. I'll explain how the lab documents work for this part of the semester. So last semester, the labs that you had, I like to call them cookbook labs, is they gave you a step 1, step 2, step 3, and basically gave you all the steps you needed to do to complete the lab. The labs that you're going to be doing this part of the semester are not cookbook labs. What it is the things that you learned how to do last semester, you showed that you know how to do them. So I'm basically going, you know how to do that. I don't need to give you directions on how to do that. So this whole top part up here is going with the assumption that you know how to set up a Windows 2019 domain controller with these specs. You know how to set up a Windows 2019 member server with these specs. You know how to set up a Red Hat server with these specs. So those are the assumptions that I'm making. The drives on it, the one thing, and I'll go through this part tonight, is we do have what's called thick drives that we are needing to provision. Reason being, when you stand up a database server, database servers can throw a whole lot of data at a drive really quickly. And if you do what's called thin provisioning, which is the default in VMware and most virtualization platforms, that drive space can get chewed up really quickly and actually override or basically fill up the drive faster than the hypervisor underneath it is actually expanding that drive space out. So basically the database server is moving faster than the operating system and the hypervisor do, and then all of a sudden it corrupts the database because you're out of space. Database servers do not like it if they run out of space, and they basically eat themselves and all the data gets corrupted. So it's really important anytime that you actually build a database server in any sort of virtualized storage environment that you always thickly provision. And what thickly provisioned is that you're actually allocating all of that space at the beginning. So if you say you have 60 gigs, you have 60 gigs carved out of that drive. Whereas normally with virtualization, what you do is you tell the operating system, yeah, you got 60 gigs, but in reality, you only have how much you actually are using with a little bit of overhead. And then as you use more, it gives you a little more and some overhead. So the hypervisor always keeps ahead of you with just a little bit extra. Whereas databases, you can't do that. You have to say, you got 60 gigs to work with. That's what you have right now. You can play with if you want to. So that's one of the big things that changes. So this particular lab, I have booked at 180 minutes to complete it. Probably about 90 of that is going to be waiting for things to build. So in this particular lab, you get all of your environment built first. Then you need to go and you're going to install SQL Server. And we're going to be installing that on Linux. One of the big things that people have tripped up in the Dayside version of this class this week is their Red Hat developer accounts subscriptions have expired. So I will walk through a quick little demo a little later on of how to go about checking your Red Hat account to make sure that it actually is able to get a subscription. Because if your Red Hat developer account is not able to get a subscription, you will not be able to install your Red Hat server, properly, which means you will not be able to get updates, which means you won't be able to install SQL Server and won't be able to complete the first lab. So a couple things that we're going to have to make sure that you guys are able to do as we go along here. Okay, so 2 labs. So servers you'll be utilizing, actually you guys are going to be utilizing HP 1U servers instead of Dell Blades. You're going to be using ESX8 on all of your servers. Your servers are should have enough storage on them. I do have externally mounted storage that has all of the ISOs you need, and I'll walk through how to find those also in the demo coming up. So the other thing about the labs this semester is not only do I have it at the initial setup part of the labs, I more say these are the servers you need with these configurations. You can ask me questions, but you should know how to build those. Like for our first lab, we're going to need a domain controller, a member server, and a Red Hat 8.7 server, as well as a gateway server. And I will try and go through the process of building a gateway server tonight, because that is something that you probably have only ever done once, if that. And it is one that tends to trip people up. So I'll go through that. And that'll help also with how you configure a Windows server in VMware and walk through those processes. So ISOs, there were ones we're going to be using this semester that will be available off your data store. You're going to have a Windows 2019 Data Center ISO, a Microsoft SQL Center 2019 Developer ISO. And again, SQL is not an operating system. It's an application that lives on top of an operating system. Usually one semester, one student will go, I can't get SQL to install. And I'm like, well, you need your operating system first. You can't just install SQL on a blank drive. There is nothing there. It needs a operating system, either Linux or Windows first, before you can actually build SQL on top of it. And then the other one is we're going to do a Red Hat Enterprise 8.7 server. So first thing that we want to do is we want to actually log into our servers. So I sent you on Sunday night in Canvas your Blades IP address. The user ID is root, and the password I sent you also. First thing you're going to want to do is log into that via a web client. And when you log in through a web client, what you will see is you'll see an ESX host client. And first time you log in, it will come in with an interface looking something like this. With most of you, what you are also going to have to do is license your ESX host. So in order to license your ESX host, you will need to go to, let's see, is that the right one? Yeah, it should be the right one. Okay. So what we need to do is in the home page for our class this week, I have some FAQs and under supplemental info. So the key one that we're going to start with is the TARDIS, VMware, and class share information. So we click on that one. And to get any of your VMware license keys, you just click on this link. It will take you to the VMware software repository. For your VMware workstation on your laptop, you want to be running VMware Workstation 17 Pro. So you're going to want to be running 17 Pro. You can request a license key from here. It will be sent to you via email. You have an account that's already been set up on there that you've used earlier this year. And so you'll just need to use that same account that you had used before. The other thing that you will need to do is grab a VMware vSphere 8X Enterprise Plus license. So you'll request that one also. And then that license is what we're going to use on your ESX host client. So let me just actually grab one of those quick here. Where'd it go? Lost my web page. Nope, that's not the page I wanted. Got too many layers of stuff here. Close that, did I? No, I didn't. There we go. Okay. So what I want to do is I want to grab that one. So I'm going to go through a request. And then it says, do you already have an account? Yes, we all do. And so we can say log in. Okay, and then what it'll do is, for mine is saying it's going to take 12 hours. It should usually be within an hour that it'll actually get you the key. Once you have the key, then we can go back to our VMware environment. And get the right screen up. And then where you put the key in is you go to Manage. You go to Licensing. You go to Assign License. And then you just paste the key in there. And then when you paste the key in there, it'll say Apply License. You apply the license, and then you're good. So the way you can find out when your license expires, so the server that I'm on right now, it expires Monday, May 8th. For the rest of you in class, it looks like most of the servers expire, let's see, between April 3rd and April 11th. So you'll have a couple days. What happens when it expires is you will not be able to start a virtual machine, and you're going to be sort of sad when that happens. So it is one of those, make sure you get a license key in order to get your server to actually make it through the rest of the semester. I'm definitely going to need this before the finals too, because you can't build the virtual machines unless you can start them. So the first thing that you're going to have to do is make sure that your networking is set up properly. So we're going to click on networking. We're going to go to virtual switches. And what we want to do is we want to set up a network for our internal network, because what we're building in ESX is we're building a private network, and that private network is going to have it that we can build all of our machines in there, do whatever we want, and it does not affect the campus network. And so what we want to do is we're going to create a standard virtual switch. We want to remove the uplink. So there's no uplink associated with it. And then we're going to call this one internal dash, and it's going to be a virtual switch, so VS. So we created an internal virtual switch. Next, we're going to go to port groups, and we want to create an internal network and an external network. So we're going to go add port group, and we're going to call this one internal, PG for port group. And then we're going to select that internal virtual switch we just created, select add. And then we're going to add another port group. And we're going to call this one external, PG. And then we're going to keep that one on virtual switch 0, which is the actual physical NIC that is associated with our virtual machine, or our hypervisor, sorry. Select add. So now what we have is we have an external, we have an internal, we have a VM network, and we have a management network. So we'll have a total of 4 port groups showing, and then we will have 2 virtual switches, an internal and a vSwitch 0. So that is your first starting point. And again, we're using the web client connected to our virtual machine, or our ESX host. So you just put in your IP address for your host. That'll get you to your host. User ID is always root, lowercase, and the password I sent you via Canvas. So once we have our first virtual machine, what we can do then is we can connect using VMware Workstation. So I'm going to put this one aside for a moment. I'm going to pull up VMware Workstation. And since I had already connected before, what I want to do is I'm going to disconnect. Because what happens is if I would have tried building a virtual machine right now and I had already connected to my host, it's not going to see those new networks that I just created, because those new networks do not propagate until you have a clean connection coming in. So what I have to do is I have to reconnect to my server. And then when I build a virtual machine, I'm going to actually be able to see those hosts. So I'm going to go build a gateway server now, because the gateway server is what we need in order for anything in our private network to get to the outside world. So to build a virtual machine, we just say create new virtual machine. Make sure you select custom. Do not select typical. If you select typical, you're going to have a really bad day and your machines are going to be flaky and you're going to have all sorts of issues and you won't know why. What it does is it takes in most circumstances, this is a proper build of how you want to build a server and put all these answers already in there for you that you can't actually change after the fact, and it's going to give you all sorts of headaches and problems. So make sure, please, 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 to use custom. I did have one person in the day class who last semester, part of the reason he had so many problems is he tried doing a shortcut by going typical, and it was a disaster. So make sure you always select custom. We are going to select either of the storage. So you should have a data store 1 and possibly another data store, and then you'll see another one called ISOs. Don't try building anything in ISOs. It's a read-only. You can't actually build anything there. So any of the other data stores you have associated with your machine, you'll be able to build to. For this particular one, I have just shy of a terabyte up here and 7.1 gigs up here. So I don't really want to build in 7.1 gigs. It's not going to really be enough space to do much in. So I'm going to use this store up here. Okay, workstation 17, that's fine. And then we want to build a Windows machine. So we're going to say Microsoft Windows. And then in our selection, we're going to go with Windows 2019 64-bit. And then we're going to call this server Gateway. And then the last part of the name, we want to use the last octet of your IP address of your ESX host. And so mine happens to be 153. Reason we're wanting to do this is all of these are going to have an external NIC on the campus network. So we want to make sure that everybody has a unique name. If two of you did gateway without putting your IP address on there, what you're going to run into is you're going to have two servers with the same name on the network, and it potentially can cause issues on the network, or if you cause the intrusion detection system to go, something's weird here, and cause problems with your traffic. So you don't want to do that. Make sure you make your machine unique. Select next. We're going to use UEFI for our firmware type. When we build a Linux machine, we're going to use the regular BIOS, but for any Windows machine, use UEFI. We don't need to do secure boot in this particular instance. For this particular one, we can look at our build document. Find it. Here we go. Oh, I don't still have it up, do I? Okay, let me get back to. Okay, for some reason, Word is not showing me my document. I close that and reopen Word and see if I can get to it. That's very odd. Unless I have it open somewhere else. I do. That's why I wouldn't let me open. Okay. So we want to find out how much storage and what type of processor do we need. So, okay, this is our gateway server that we're building right now. So the gateway server is going to have 4 gigs of RAM and 1 processor and a 40 gig thin hard drive. Okay, so we're going with 1 processor, 4 gigs of RAM, which happens to be the default. And we want to put this one on the external network, which is fine. That's what it put it by default. Controller type is just fine. Disk type is just fine. We're going to create a new virtual disk, and we only need a 40 gig disk. If we were thickly provisioning this is where we would select allocate all disk space now. Allocating all the disk space now would be thickly provisioning that disk. This particular one, because it's a gateway, we don't need it thickly provisioned, so we can just select next, select next, select customize the hardware. Now we want to remove this sound card because our virtual machines don't need a sound card. We want to add a second network adapter. That one is going to be on our internal network that we created. Then we're going to click on our DVD drive, select Use ISO image file, browse, go to our data store, go up to the server name, go to ISOs, double click, go to Windows Server. select Windows 2019, select Open, then we can select Close, and Finish. And our server starts building. So and then we need to make sure when it hits this screen, we hit any key in order to actually kick it. So that is one of the nuances of using UEFI BIOS, is you do have to, during the boot process, hit a key at that point in order to kick it over to the CD. Otherwise, it will just boot right through it and never actually boot from the ISO image. So that's just one word of warning when you're at that point. While we're waiting for this one to start building, actually, this is going to go pretty quick. We're going to select Next, Install Now. We always want Windows Server 2019 Data Center Desktop Experience. If you do not set Desktop Experience and instead go for the one without Desktop Experience, you will get what's called Windows Core. And if you get Windows Core, what it means is you only have a command line, you have no GUI. And to get the GUI, you have to reinstall the operating system. So don't let that be you. Usually somebody does that at least once during the semester. We select Next. Accept the license terms, select Next. Custom install, Next. And that's going to run for a little bit. While that's running, we can get started on the process of getting our Linux server configured. So we can go back to we're going to create another virtual machine. We're going to go custom, Next. And we want to put that in our bigger storage. Next, Linux, Red Hat Enterprise 8. Oh, wow, they have 9 now. Cool. Next. This one is going to be Vulkan. And you'll see that I mixed my my science fiction. We have both Star Trek and Star Wars represented in this week's lab. So for those purists, I apologize. But for the rest of you, it just is an easy way to come up with naming conventions. So server name is Vulkan. This one is Linux, so we want to go regular traditional BIOS. Select Next. And on this one, we want a different number of processors. So let's, oops, that's not going to help there. I need to get to that screen and flip through. So we're looking at Vulkan. Vulkan is going to be 4 gigs of memory, 2 processors, and a thickly provisioned 60 gig hard drive. We want 2 processors, 4 gigs of RAM, internal network is what we want to be on. Use the default for the disk types. Create a new virtual disk. Going to be 60 gigs, and this is where we want to make sure, because we're thickly provisioning it, we're doing allocate all disk space now. Select Next. Select Next. Customize the hardware. Again, we don't need that sound card. We can go click on our CD, select ISO image, select Browse, click on the data store, click on the server name, go to ISOs, Red Hat 8.7. Select Open, select Close, and Finish. Okay, so that one's now running in the background as well. So the one thing with your virtualized environments, because as we go on, we're going to be building a lot of servers. 3 servers at a time is about the max you can do on your virtualized environment. If you try building more than 3 servers at a time, what you're going to run into is that it will take 2 to 3 times as long. So it is one of those that you can do up to 3, and they're going to finish in about 30 minutes or less. If you go 4, it's going to take over an hour. So just be aware that you have a diminishing returns after 3 servers. So as you're building out, just be aware of that. Okay, so it's going to take a little bit for that to get rolling. So see how our gateway is doing. We're at 20%, so we're chugging along. It's going to take a little bit. Okay, and I'm actually going to go for a third one. Create another virtual machine. I'm going to go into that drive. It's going to be a Windows Server 2019. This one's going to be Mars. I guess I went Greek gods too, so I really mixed metaphors all over the place. UEFI again. Okay, on Mars, this is going to be our domain controller. So oops, I keep doing that. We need on Mars is going to have 6 gigs of memory, 2 processors, and a 40 gig thinly provisioned hard drive. So 6, 2, and 40. Or 2, 6, and 40. 2, 6. Internal network. New disk. And a 40. Customize it. Get rid of the sound card. The reason it puts a sound card in there is because you're building it from a desktop that has a sound card. And go to ISOs, Windows Server, Windows 2019. Okay, so we have everything set up. Select close and finish. And then that one's going to start running. So I wouldn't spin up more than this while you're starting to get ready. So, okay, so our gateway should be getting pretty close. It's getting closer. Vulcan is getting closer. Mars is going to ask us some. So I'm going to bounce back and forth between these servers, and I'll try and let you know which server I'm on and what pieces that we're working on at the same time. I'm trying to make sure I can get you as much information as quick as I can. That's going to be really helpful for working on your labs this week. Oops, I didn't get Mars fast enough. Okay, so if you don't click into the screen early enough, what will happen is you'll get this little timeout thing. If that happens, what you actually have to do is right-click, power, and restart the guest. And then when it actually gets to the point that that comes up, you need to make sure you click into the screen. That is one of the hazards when you're doing multitasking and trying to do multiple things at once. You can run into the problem that you aren't able to actually click on what you need to when you need to. The other things that sometimes will happen is your mouse will get all funky like mine just did here. That you click into this screen and it disappears on you. See if I can get that to be better about that. Maybe. Okay, so next. Well, now, and this is Mars. And we just need to kick off the installation script. Come on. Okay, desktop. Data center. Desktop experience. Accept the license terms. And next. Custom install. Next. Come on, get to the point so I can just kick. There we go. Okay, so what I'm going to do is I'm going to out of here and then go back to okay, so we went in, we did our ESX configure the networks. So we have our internal NIC, our internal network, the no NIC associations. We did an external and internal port group, and we got those all set up so that we can actually build our servers with them. So on the gateway server, once we actually finish coming up, what we're going to do on that one is we're going to configure the server, and I'll walk you through the steps to do that. It's going to be the same basic configuration that we'll use for setting up any Windows server for the rest of the semester. We're going to make sure that one of the NICs is able to pull a DHCP address. And then we're going to label that one external. And then the other NIC we're going to label internal, and then we're going to assign it a static IP address. And then what we're going to do is we're going to do what I call around the clock for setting up our configurations. We're going to turn off IE enhanced security. We're going to set the time and date. We're going to go to the NIC labeled, we're going to label the NICs external and internal, set the internal to 192.168.79.254. Then we're going to change the server name to gateway and whatever your last octet of your IP address is. We're going to install VMware tools, and then it forces us to do a reboot. Once it reboots, we're going to then configure our actual NAT gateway, and then we will take a snapshot to make sure we have a functioning NAT gateway saved so that if anything happens to this server for any reason, we can revert back to a known good state of a NAT gateway. For all of our servers, this is going to be really, really important that you do these snapshots, because part of the challenge with Microsoft SQL Server on Windows is once you get past a certain point of the install process, it does not uninstall cleanly and causes you all sorts of headaches. And if you can revert back to a snapshot and then reinstall from that point forward, your life is going to be a whole lot better. Part of why that is, okay, I actually want to grab a different slide deck. Let me pull up the other slide deck. I wanted to do some other information here. Actually, while I'm waiting on that, I'm going to give you, yeah, that wasn't one in day one. That's not funny. Okay, well, we'll just double check where we are on these. We're at 49%, set 12%. And the Red Hat server's further along, but we need our gateway before we can do more on that. Okay, so what I'm going to do is I just need to change that. Don't think that's the right. Grab that. Okay, I'm going to grab this for a second. And nine. Go. Yeah, I didn't think that was right. Where's the better? Sorry, I'm mumbling to myself. Slideshow from the beginning. Okay. So just a reminder, grading scale for this semester. It's not a standard 90, 80, 70 curve. It is to get an A, you have to be above 95%. To get a minus above 91%, a B above 84, B minus above 81, a C above 74, C minus above 71, and then we hit the cliff. And so you really don't want to be in the lower zone here, because after a C minus, it drops really quickly from a D plus to an F. So just be aware, don't stay in this zone. If you're there now, you got some work to do to make it up before the end. It is possible. The way things are weighted, 50% of the class grade is the practicals and exams. For this section of the class, we will have 2 practical exams last week of school. You guys, since you're online, what it'll be is they will be 2 separate exams that you can take either together or on separate days. Each of the exams will have a 2-hour window in order to take them. The first exam will be a build exam, where you will have a pre-configured environment that you built as a lab the week before, and you will then, I will give you a document and say, build this SQL environment on top of this environment per these specs. The second day is that you're going to utilize that environment to then do things that I ask you to do that we learned along the way in our labs. So the labs are going to be really, really important this last 8 weeks, because everything that you do in the labs prepares you to do the practical exam at the end of the class. And this is really time is going to be your enemy, because this is an open book, open note, open web practical exam, but you're time constrained. And so what it is time is your enemy. So you need to be able to actually have done this before so you can be efficient in how you actually tackle these exams. Late work. So late work has been a problem. So just a reminder on the late work policy is that I can and may start deducting points now because people are sort of being habitually bad about turning things in on time. So please make sure you get things turned in on time. Also, the attendance policy, make sure that you're showing up, because if you miss up to 15% of the class, you can get academically dropped. And I had to send out some letters to people today that are on the bubble about getting academically dropped because they're getting close to that 15% missing attendance. Okay. We already went through some of that. Okay. It's the important things that I need to tell you. Okay, key components of SQL Server. So the SQL Server is a relational database. So back when we were playing in AWS, we got to play with relational databases. Primarily, we were working with MySQL, but they all use a similar structure of a language called SQL Query Language, or SQL. Microsoft SQL has been around a long time. Since the 80s. So it is one of those that originally Microsoft and Sybase got together. Their relationship didn't work out so well, then they parted ways. But that's what came with Microsoft SQL Server. For our class, the things that are going to be really important is to realize that there is a database engine, the SQL Server service, which when we start playing with the SQL Server on Windows next week, is going to be the bane of your world, because if the SQL Server service doesn't start, you can't do anything with your SQL Server. And then the other one that's going to be really frustrating for you is going to be the SQL Server agent. The SQL Server agent service is what actually runs things like backups or any sort of jobs on the system. And if the SQL Server agent isn't running, none of those work. SQL Server browser is something that we aren't going to be turning on. It's something that's rarely used in production nowadays, because what it is it's a advertising feature for the server, where on a network it basically goes, "Hi, I'm a SQL server and I'm here, please connect to me." And since SQL servers usually are keeping data that you really want to keep protected, you really don't want to have the server sort of advertising where it is so anybody and everybody can connect to it, which isn't a good thing. Rest of the things here are things that DBAs are going to be taking care of, so we aren't going to really cover those this semester. SQL Server has been around a long time, so these are all the versions that have come out over time. We're going to be installing SQL Server 2019 on Windows and SQL Server 2022 on Linux. SQL Server 2025 will be coming out in beta probably in October of this year already. So Microsoft's roadmap already has that Server 2025, SQL 2025, and Windows 12 are already on the roadmaps. So, part I was talking about where I said that when you build the server and if you install SQL and things go squirrely and you try and reinstall and you all of a sudden find yourself in the weeds really bad. The reason is this idea of SQL Server instances. Because what SQL Server has is that the first time you install SQL on a server, it creates a master instance that is the primary instance on that server. And to get to it, you just use the server's name. So that is your base instance. And it's called a primary instance. And you just get there using the name of the server. SQL is designed so that you can have that basically act like a hypervisor for databases. And that one instance can have up to 50 named instances on that same server. For the named instances, the way you get to those is it's the server name slash the named instance name. If your SQL Server install didn't work properly, but worked enough so that it left a footprint that said there is an instance on this server, the second time you try and install, what it's going to do is create a named instance, and the third and the fourth, and then you're going to try and connect to it remotely, and you're going to be all confused about why you can't actually connect to it because you're trying to connect to what you think is the primary instance, when in actuality, what you had installed was a named instance. So this is one of the places where things can go squirrely really easily for people in these labs. When we work on it on Windows next week, we'll probably have 1 or 2 people that actually run into that. So why do we want to do these instances? Well, part of it is that SQL Server licenses in production are very, very expensive. A SQL Server license for a database enterprise license is about $10,000 a year. So you want to get your money out of that cost. And the way to get your money out of that cost is you put it on a really beefy server. And then that really beefy server can have up to 50 named instances, and each named instance can actually run a different flavor of, it's a security isolated version of SQL. So it's like you have 50 SQL servers living on that one box for the cost of that one license. So it can be a pretty good deal. So cost reduction is one of the big reasons why these named instances are good. Also, you have for maintenance and development, gives you isolated environments. For security, you have everything isolated from each other. And then if you want to do standby servers or other thing, it works pretty well. There's 4 core versions of Microsoft SQL Server: Enterprise, Standard, Express, and Developer. We're going to be working primarily with Developer, which is the same as Enterprise, but you can't use it in production. Standard, the limitation on Standard, and I'll just go through it. Oh, and the other thing, SQL actually can be installed on Linux. So you have a Microsoft product that actually runs best on Linux, which is really, really weird because Microsoft for a long time was very anti-open source, anti-Linux. So this is one of those things that initially I was like, for 20 years, Microsoft's been actively trying to kill Linux, and all of a sudden they're embracing it and they're making what their flagship product work on it. Okay, this is weird, but it's picky. It only works on Red Hat Enterprise Linux, SUSE Linux, or Ubuntu. Can't use any other flavors of Linux. No other distros will work with it. Part of why Enterprise is so expensive but so cool is you can have an unlimited number of processor cores. The operating system memory is only limited to what the physical hardware's memory is limited to. The database can be up to 524 petabytes in size. Definitely can be used in production. And for virtualization, you can have unlimited installs, which is the beauty about the enterprise license. So what you can have is if you have a big ESX vCenter type deployment, you get one enterprise license, you can use that one license on your whole vCenter environment and spin up as many SQL servers as you need. So rather than having to have all these named instances, you can actually have unique SQL servers. So enterprise is a really cool thing. It's expensive, but it's worth the cost. My old environment, we had 15 standard licenses. And what a standard license is if you buy a box from Dell or buy a box from HP and it has Microsoft SQL installed on it already, or a license for Microsoft SQL, what it is a standard license is tied to a physical piece of hardware. You can only do up to 4 sockets, 24 cores, 128 gigs of RAM. Still can do that 524 petabyte database size, which is ungodly huge, but it's licensed per server, whether physical or virtualized. And license for standard, you're talking about $800 a server. So it's still expensive, but if you're a small shop and you only have 1 or 2 SQL servers, that might be a great solution. If you're like a lot of shops, you're going to have a lot of SQL servers out there. And running one enterprise license in a virtualized environment to spin up as many servers as you need is pretty standard way to do it. Express is a free version. So if you install, let's say, Visual Studio on your desktop, a lot of times what it does is it has a database engine piece of that particular piece of hardware, and that will run SQL Express. So it's a free version of Microsoft SQL, really super lightweight, designed to basically help support applications on the desktop level. And then developer, same as enterprise, except you can't use it in production. And they say you can't use it in virtualization. So if you get a test question, if you're ever sitting for a test and you see a question about this, The Microsoft Kool-Aid answer is no, it is not actually allowed in virtualization. The real reality is you can use it in virtualization all you want and it works just fine. So this week, we already talked about that. So our NAT server. So our NAT server is the piece that we're going to need to get from our internal private network to the outside world. And so let's go build that. Let's see, it should be ready for us to build. That one should be there. Okay, let's go back to our gateway server. Really? No, you should be finished by now. I think it might be. I think it's not giving me real information. Nope, it was. Wow. Being slower than I would have thought. Okay, I'll go back to information on the lecture. Sorry about that. Thought we were moving further. Okay, so with NAT, what NAT is network address translation, and we played with NAT a little bit when we were in AWS. So if you have a private network and you want to get out to the internet, you need to have some way to translate those private network addresses. In our case, we're going to be using the 192.168 subnet range, and have it so that we can get to the campus network, which happens to be on the 10.10.x range. And so what we're going to be doing is setting up a Windows server to act as a NAT gateway. Normally, you're going to use a router to do this. So what we're doing is a software-based router with this box that's going to do this NAT translation for us. When we were in AWS, we just had a little service that we just said, we need a NAT gateway, and we applied the NAT gateway into a subnet. And then we gave it a routing table and said, anybody requesting from this private network to get to the outside world, go to this NAT gateway and get out. We're just having to build it ourselves, rather than having a nifty little widget that we can just point it to and do a little configuration. The other thing that we're going to be building is a domain controller, which you guys should have built a few of at this point in the program. So we're going to have an Active Directory domain controller, and our domain is going to be trantor.local. So we have our Star Wars reference there. And then we're going to have our Red Hat Enterprise 8 server. So Red Hat Enterprise is probably the most common flavor of Linux that you're going to find in IT shops. Reason being is Red Hat is now owned by IBM. Before it was owned by IBM, Linux or Red Hat Enterprise Linux is one of the few distros that has offered support from the very beginning. That's part of why Red Hat is they went for the enterprise customers, and they went, we're going to use an open source product, but we're going to actually invest in the support side of it. We're going to invest in making this reliable and robust to put into the data center, and have it that if that CIO or CFO won't touch open source because they're worried about, well, if it breaks, who do I call? We're going to have that person that they can call and the support network to actually support that. So Red Hat Enterprise Linux is one that, because of that, they have a whole lot of market share in the data center, because it's a safe distro to work with, because you don't have to have like an uber geek on staff who knows how to provision kernels or anything like that. You're able to contact a third party if you get in the weeds to help you with that and buy support. So what our rough diagram of what we're going to have is, we're going to have our NAT server. We're going to have our private network on the inside, which will be the it'll be the 192. These aren't proper IPs. Campus network is the 10. But we'll have a Red Hat Enterprise Linux server, domain controller, and a SQL Server management server, which is going to be on the third server. And that's what we'll be building out. So while we're waiting for that other server to build, the attendance code for today is P1D3P1P3R. So just give you that for a second, and then we'll jump back over to the servers. And hopefully our servers are at the point we can start playing with them now. Everybody get the attendance code? Okay. So I'm wondering if 3 servers at a time is pushing it on these servers, because it did seem to slow it down significantly, pushing it at 3. Now maybe 2 would have been a better idea. Okay, on the Red Hat server, we can at least get a little farther. So English. Okay. So for the network, we need to go in and our host name is going to be vulkan.trantor.local. Help if I'm actually in the right field. Okay, why am I not getting? Like that. And we want to configure our NIC. Okay, so we first go to IPv6. And we want to disable that. And we want to go to IPv4. Switch that to manual. We're going to add an address. And then the address we want to add, go back to our worksheet. So Vulkan, the IP address of the server is going to be 192.168.79.50. And numlock didn't work. Okay, 192.168.79.50. Net mask is going to be a /24. Gateway. So the gateway is going to be our gateway server, 192.168.79.254. And where that you can find on our document is the gateway is listed here. And that is the, when we build our gateway server, that actually will be the IP address of our gateway server. Okay, DNS servers. So this is going to be one of those things for lab 1. We're going to want to use 10.1.1.20, comma 10.1.1.22. So these are the campus IP addresses. For lab 2, when we're going to actually add this server to the domain, then you're going to change that DNS server to point to 192.168.79.100, which is going to be our domain controller's IP address. So just be aware, for the first part of the setup, we're going to use the campus IPs 10.1.1.20, 10.1.1.22. Lab 2, we're going to switch that to 192.168.79.100. So we'll save that. And then because this is Linux, we actually have to turn on our NIC to actually activate our NIC. Then we can say done. KDEP, we want to disable because we don't need it. Installation destination, we just need to click into that, make sure that it's saying our 60 gig drive is where we're going to install it. Okay, at this point, we can't go much farther because our network gateway is not up yet. So what we're going to do is see if our gateway server is in a happy place. And it's being really slow. So is Mars. Okay. Can't go much farther. Oh, we could. Yes, we can go to those two. But we can't do date and time, and we can't connect to Red Hat yet. Oh, good. Now we're at restart. Finally. That took a long time. Okay, we're just waiting for that to reboot. And this is the part that I was talking about where you have a lot of hurry up and wait. And I'm trying to minimize it for this one, but it's still that when you're dealing with Windows, you're going to deal with a lot of watching little spinny things, and you're going to watch little bars going across the screen. And it's a lot of time where you just go do, 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 and just wait for things to happen. It's the part that actually is the toughest with Windows sometimes, is how to stay productive when you're having to monitor what's going on. So you can't just sort of click it and just ignore it. But you can't just sit there for 10 minutes and just wait for something to happen as well. And it's much better than it used to be. Is setting up a single Windows server 10 years ago was like a day-long process. So it is one that they've definitely gotten a lot faster, and it's not quite as painful as it used to be. But after getting used to cloud services where it takes 4 to 5 minutes to spin up a server max, spinning up a Windows server is going to feel really slow. So just be prepared for that. This is one of those, especially if you have multiple, like an external screen to your laptop. It makes it easier, so you can be working on something else, like possibly even working on another class while you're building servers and waiting for things to happen here. But you can still, as soon as it gets to that next screen, you can move it on to what you need to do next. It's like Mars is almost going as fast as what the gateway server is. It's weird. Any questions so far while we're waiting for the gateway server to come the rest of the way up? Making sense what I'm covering? Things familiar to what you've done before, or are we getting into territory where you're going, what are we doing here?
A little bit of everything.
Okay. If there's something where you go, could you show me that again? If you see something and you're like, wait a second, what was that? Let me know, and I can repeat it, or I can explain a little more what I'm doing. Because I am trying to get as much as I can in that you're going to need for the labs in a very short time. And I am sort of going to be bouncing around between 3 different servers too. So come on, little server, you can do it. We aren't even using that much CPU or memory. I can close that. That won't help that much, but. So for the password, when you set up your servers, we're going to get there in a moment. What you want to be using is password 01 with a capital P for all the Windows servers. Reason being, if you get stuck, if you have problems, and you need me to help, you can ping me with an email. I can log into your servers remotely then because I know the password. I can take a look at the environment and then give you insights about what you can do to fix it. Rather than having to track it down where we both have a chance to talk at the same time, which a lot of times is going to be more difficult to actually make happen. I found over time it's a much more efficient way to do it, because then I can just drop into your server when I have a couple spare minutes, look at it, and usually I've been doing these servers enough for these labs that I'm like, oh, I know exactly what went wrong, and I can give you a nice short little answer and say, here's what you need to fix. So it is for troubleshooting reasons that we do that. And then for the Linux server, what we do is we do password 01 exclamation point for that account. But that will make life much easier for troubleshooting as we go. Like, you don't have to, but I would highly recommend it. It just makes troubleshooting much, much easier. So has anybody tried connecting into your VMware server, or had any problems getting into your VMware servers? Or has everybody been able to connect in already to them? Or you haven't tried yet?
It finally worked fine for me now.
Okay, good.
I connected to it. I just haven't set up the internal and external yet.
Okay. Getting closer. Looks like my saying 3 was wrong. I should have just gone for 2. It is, you can see how much it slowed down when I went to 3. Even though it's not memory constrained. That's the crazy thing, is, looking at it, it's not CPU constrained, it's not memory constrained. If anything, it's probably, I'm guessing, disk IO maybe. Don't know. Because we aren't running the storage in a RAID set, and that could be because we're just running off a single platter. If I did multiple platters, then I would have it that we would have about a third as much storage as what we have to work with, and that wouldn't be enough for the labs that we're trying to do. So it was more storage, less speed. It's painfully slow. I'm sorry. What I can do, I can connect to a different server. So it's not going to be a ESX8, it's going to be an ESX65, but I can show you a couple things that may help here, since we're going to be running short on time.
Do we want the gateway to be discoverable by other
Yes.
PC?
Yes, you do. So yours already built?
Yeah, mine built pretty quick, actually.
You-
I was
did you
able to
just
get
do-
all
Did
four
you just
built.
do? Oh, you got all of yours built?
Yep.
Lucky you. Okay, so, oh yeah, finally got it up. Okay. Okay, so password 01 for our oops, help if I can actually type. Okay. So what I can do is I can show you a built environment and sort of walk you through a couple things on here. So our gateway server, once we have it spun up, things we're going to want to do for configurations. So we want to do our ID enhanced security. We want to turn that off. We don't do that because the only browser we have on here is Internet Explorer. You go to launch and what's going to happen is you're going to get all these really annoying security nags every time you try going to any single web page. So turning that off initially will help make your life much easier. Next thing we want to do is time zone. So we want to set the time zone. So change time zone, select central time, then also go to internet time, change settings, update now, select OK, and that will get it so that your server is actually updated to a network-based time server to bring it current. For your NICs, what you want to do, so when you go in, you will see one of your NICs that will have a dunwoody.tech.mn.us. You'll want to right-click on that one, go to Properties, turn off IPv6, and then right-click, rename it, and rename it External. For the internal, which will be the other one, you right-click, rename that to Internal, go to Properties, go to IPv4, set it to 192.168.79.254, which is in our worksheet. Subnet mask is a /24, so 255.255.255.0. Do not put in a default gateway or any DNS settings. We're only putting an IP address and subnet mask on that one. And turn off IPv6. Once that is done, we will then go up and do the computer name. So you go to change. Computer name again is going to be gateway, and then the last four or the last octet of your IP address. So mine happens to be in this case gateway 158. And then you'll select OK. It'll say you need to reboot, say reboot later. And then lastly, what you want to do is right click on the tab, go install VMware Tools. When you do install a VMware Tools, it will then mount the VMware Tools ISO. It will usually pull up a little splash box in the lower right-hand corner to do the install, but it only stays there for a little bit, this little guy. So you can either click on that, but if you miss that, the other way you can go is you can click on File Explorer. Whoops. Go to the DVD drive and click on Setup 64, and that will go through the install process for VMware Tools. The reason you want to install VMware Tools is that gives you video drivers, so you can actually resize your virtual machine to your screen size. It will give you network drivers, and it will give you better drivers for disk operations, mouse, and keyboard control. So it's really important to make sure VMware Tools is installed on all your virtual machines that you build on all your Windows virtual machines. Once you have all that done on the gateway server, next step, what you want to do is we're going to make this a actual NAT box. So it'll require a reboot once you do the computer name and the VMware Tools. You'll reboot it, comes back up. Then what you want to do is go to Manage, Add Roles and Features. Next, next, next. Select Remote Access. Then you'll go through a couple next, and then routing will be the piece that you select. It'll go through an install process. It'll force a reboot. Once it gets done with that, then you'll go to Tools. You will go to Routing and Remote Access. And this will be red instead of green, and I'll actually disable it and go through the configuration process again. This is Windows, it's not fast. Okay, so this is what it'll look like when it's first configured, and it'll also have a little warning up on the notification flag. Right-click, configure, select next. We want NAT, network address translation, Select next. This is the important part. You need to have 2 NICs showing here in order to proceed. If you only have 1 NIC showing here, you want to hit cancel, cancel out of this, give the server a little more time, and then come back in, because you can't proceed past this until you have 2 NICs showing here. You want to select the external NIC, because that is our public interface connected to the internet. So we want to select external, select next, and then we just do next all the way through to finish. And then it will start our NAT gateway. And our NAT gateway is critical because we can't do anything else until our NAT gateway is actually functional. Once our NAT gateway is functional, because this is Windows, even though this is one of those few times it doesn't say, please reboot your server in order to make sure that things are working. It doesn't this time, but rebooting it actually makes it so it usually works better. So I would recommend at this point to do a reboot so that everything actually plays nice. So do a restart. Okay, so we've gotten our gateway server built. Once our gateway server is built, then we can actually go back to Mars and start working on Mars. Or sorry, Vulkan, and start working on Vulkan. And I'm going to cheat on Vulkan, so I'm going to do one thing on here because for sake of time, I'm not going to configure the gateway server that we built. And so what I'm going to do is I'm going to cheat this one. And I am going to point it. See what I can do. Yeah, I'll do it this way. I'm going to flip it to the external network just so that I can get it installed. So I can show you this process because this is where a lot of people are going to have some problems. I do have everything else I can keep the same. Or no, I can't. Sorry, I have to change. So this part isn't something that you would want to do on yours. Okay. And I want to do this just so I can show you the rest of the steps for setting up the Windows or the Linux server. Okay, so the big thing is you have to go to Red Hat to license your Red Hat server. And you need to have, this is why you have to have your gateway server up first. Since on this network, I don't have the gateway server up, I'm just having this server point directly so I can show you this step. So you need to connect to Red Hat. This is where you put your Red Hat user ID. Not your email address, it's your Red Hat user ID, and then the password associated with your Red Hat account. And then you say register. If you run into problems, which probably about half of you are going to, with the registration process failing, what you're going to, usually what it'll be is it'll either come up and say that you can't get a subscription or something else isn't working. Then what you need to do is you need to go to the Red Hat website. Let me get to a web browser. And what you'll need to do is go to Red Hat Developer. To do a search for Red Hat Developer, go into the, so it's developers.redhat.com, log in. Oops, that's right. No, come on. There we go. Okay, so then you need to go to your Red Hat user account up here in the right-hand corner, and then go to subscriptions. It'll redirect you. And what you want to have is that it's showing that you have 2 active subscriptions. So what happens sometimes over time, because your Red Hat developer subscriptions are good for a year. You may not have actually used any of your Red Hat subscription stuff for some time in the past, and what you need to do is reactivate it. So part of the process that we just did will a lot of times reactivate your account. The other thing that sometimes happens is when you first go to the Red Hat developer site and log in, you may get a splash screen that says, here's a new EULA that you need to accept. Click on this box and say accept, and that will then renew your subscriptions as well. So you need to have active subscriptions available in this screen in order to register your machine. So as long as you have active subscriptions here, then when you go into the registration process here, it will say one subscription attached to the system, and then you're good. But you need to have that step completed before you can proceed. Then we can go to our installation source, and we're doing it from Red Hat, software selection, server with GUI. Come on. And then we can do date and time. We want to do Chicago, so just point it towards Lake Michigan, and then it'll do Chicago. And then we need to set a root password. So for root password, do password 01 exclamation point. And it's going to complain at us. So what it does is you'll see down here, if the password fails the dictionary check, it is based on a dictionary word. You have to press done twice to confirm it. So we're going to do done. It's going to complain. Press done again, and we're good. Now we want to create a user. So you want to create a second user, and the key thing here is make sure you check this box. Make this user administrator. If you do not check that box, your life is going to be really sad. Make sure on this user account you can create whatever you want. I'm going to go another sci-fi genre and go back to old school Buck Rogers, and I'll set a password. And then done. Okay, so we went around the horn. So we did our network host, we did kdemp, installation destination, registered with Red Hat, did our software selection, installation source, time and date, root password, and created a user. Then we're ready to begin our installation. And that'll start the install process for Red Hat. The biggest place where people get off track is the subscription, attaching a subscription to their machine. And that's one of the places where people really get messed up. Okay, so jumping back over to the other one with the built-in network. So once you have your domain controller built, and you have Mars out there, then you'll see that you have to log in with a domain. So making a domain controller, the biggest thing when you're making a domain controller again is you just go to manage, add and remove features, next, next. And that's the Active Directory domain services is the first thing that you install. Go through the rest of the screens. It's going to take forever to install the Active Directory domain services. Then it'll come up with a little icon up here next to the flag that says, do you want to promote this to a domain controller? You say yes. And then this is the first domain controller in a new forest. And then the domain name is trantor.local. Then it'll request a reboot, and then that'll get you so that you can actually get your domain up on the machine. Once the domain is up on that machine, then you're ready to go build the next server, which is then going to be Jupyter, which is just going to be a member server. So it's a Windows server that we set up just like we set up Mars and we set up the gateway server, except only a single internal NIC, which is the same as what we do for Mars. And then what we want to do on that one. So once it's a member of the domain, you want to make sure that you actually log in with the domain account, not the local account. So the first time you do that, what you're going to have to do is log in with Trantor /administrator, and then the password. Otherwise, you're actually just logging into the local administrator account. That's going to be really, really important next week when we install Microsoft SQL on top of these servers, because if you install it locally, you can't use Active Directory authentication for Microsoft SQL. So next week, I'll be harping on this one a little bit, but we're going to log in here. Okay, so on this one, we have to join it to the domain. To join this computer to the domain, the important thing is that you have to have it do two things. So we do all the configurations similar to what we did before, but one of the important things that we have to do is our Ethernet. We'll need to have it so that our IP DNS server is pointing to the IP address of Mars, because Mars is the authoritative DNS server for our domain. So we're pointing the DNS server to Mars. Once that DNS server is pointed to Mars, then we can actually join the domain, which is where we go to computer name, click change, and then this is where we put our domain in, trantor.local. And as long as everything is working properly, when we do that, it'll say authenticate to Mars. We do administrator with password 01. It says welcome to the domain, reboots the server, and we're good to go. I do have a cheat sheet out there on that, out on Canvas as well to help you guys. Once we get that all set up, the other thing that we are going to do at the very end of the lab is we connect to the class share. Again, I have that FAQ of how to connect to the class share. When you connect to the class share, you will then have a file that you need to bring local called SQL Server Management Studio, so SSMS. You'll bring that local. And once you bring it local, you'll go through and install. And then what that will do is that we'll have a utility called SQL Server Management Studio. And then the last part of the lab, what you do for lab 1 is you actually connect to the SQL server that you're going to install on Linux from the command line. And then the last screenshot that you will have for the lab is actually this little Linux guy, this little Linux penguin next to the database server. And then you had built this test database on the actual SQL server. And that's the end of lab 1. Lab 2 is going to be more complex. So I'm not going to cover what's in lab 2 tonight, but this will get you so your base servers are up, and then the instructions that are in the labs pretty much walk you through the steps that I didn't show you tonight. What I showed you tonight it was a lot of the stuff that you sort of learned last semester. You may have forgotten some. And I wanted to make sure that you had a refresher and something to go back to as a review item as you're getting your servers built, getting the environment built, because the important thing is to get this environment all solid, stable, and ready to go. And then once you get things like Mars built and it's a working domain controller, what you're going to want to do is go to snapshots, take a snapshot, and in this one I can go clean domain controller. And then take a snapshot, and then I know I have a snapshot of a clean domain controller that I can go back to. So if something goes squirrely on my domain, I can just revert to that known good domain controller image and rebuild from that point forward. Same goes for Jupyter, and same will go for Vulkan, is that you want to have that nice clean server go back to point before you do any major work. So like once you get your Linux server up and running, take a snapshot of it before you install SQL Server on top of it. And in the lab for SQL Server, what it's going to be is, let me get to the doc. There it is. You're going to just go to the command line on your SQL Server once it's built. You're going to run this script. You probably are not going to be able to copy paste that, so just be careful in typing it. Because it's really easy to make typos on that one. So you basically go and you are pulling a repository. You do a one-line install. It installs it. And then we're going to run the setup for the configuration. One thing when you're doing this particular step, this is where you set the password associated with Microsoft SQL. So right here, this is really important that when you set that password, make sure you document it because that's what you're going to need to connect to it later. In Microsoft SQL, the God account or the administrator account is called SA, which stands for System Administrator. But it doesn't say user ID, it just says put a password in. And you're just like, well, what password am I putting in? And the password is for that main account. Then we're going to go down and make sure our SQL Server is running. We make a hole in the firewall. Since it's Linux, we're making a change to the config state. And then we need to reload the firewall to change the running state. Once we've done that, then we're going to install some SQL command line tools again, pulling the repository, doing the install. And then this one, there should be a sudo in front of this. I forgot to re-add that in. So just be aware on that particular line, you do want to do a sudo command in front of that, and that will bring you to a SQL prompt, which looks like this. It'll be the number 1 with a greater than symbol next to it. And then what we'll do down here is we're actually doing SQL queries. So you'll put that line in, and then you'll type the word go, and then it will run those 2 lines. And then we'll add some additional scripts. So we're going to create a test database, add some inventory items into it. And then we're going to run that one. And then we're going to do a query against our database that actually looks at the database quantities to see how much is in there. Select go. And then we'll quit that. And then we jump over to Jupyter to do this step, which I sort of walked you through just a moment ago. And that's lab 1. So lab 1, the biggest time part of lab 1 is going to be getting your environment built for this. Once that is built, the rest of the lab goes pretty quick. The rest of the lab is probably 45 minutes. The hour plus is going to be getting your servers built. And that's lab 1. Lab 2, I think I have, yeah, is going to be a little more complex because what lab 2 is going to do is it's going to make it so we can join our Linux SQL server to the Windows domain. And so this is going to be doing some PowerShell and also doing some key transfers between the 2 servers. So this one has a lot of steps, has a lot of typing. So just be really, really careful on that one, but all the steps are documented in here. So it's just one that precision is going to be really important. You don't need to build anything more for lab 2. So lab 2 is really just working your way through it. I do have lab 2 as a 200-minute lab just because you are typing a lot of PowerShell and you're also typing a lot of stuff in the Linux command line. With bouncing back and forth between servers, make sure you know which server you're on at various points because you're going to bounce, because here it says terminal prompt on Vulkan. And then down here, okay, so we're still on Vulkan. And then we jump over to our domain controller over here. I tried putting it in bold to make sure that you guys know when you need to bounce back and forth between servers. But it is one that sometimes people think they're should be doing something on one server when they should have really flipped to the other server. Questions in the last minute we got left. There's a lot there. We're definitely working in a whole different type of territory than we were working when we were doing in the AWS stuff. You got a lot of hands-on stuff that you're working on the servers, configuring the servers, building the servers, interacting with multiple servers together. So this is a lot like what you actually do on a normal on-prem type environment, whereas the cloud stuff is a little more abstract. And sometimes it's a little harder to wrap your head around. The biggest challenge with this one is the time it takes things to build. Oh, one thing I wanted to just show you as a sort of trick to help you make your lives a little easier. Virtual machines have this problem, and this is one of the annoying things that Microsoft did. Microsoft, for some crazy reason, decided that power management for laptops needed to belong on a server. And you want to turn that off. So what you want to do is you want to go to, I think it's display settings will get us there. Yeah, we want to go to display settings, and then we're going to go to power and sleep. And we want to turn off that it actually puts the screen to sleep. And then we also want to go to additional power settings, go to high performance, change plan setting, and do not turn off the display. Part of why we want to do this is, never. Come on. Save changes. VMware has this little weird glitch. And what will happen is if the operating system decides to turn off the monitor, but it's a virtual machine, it puts it into what I like to call the coma state, because you can't interact with it because it's turned off the monitor, but it's actually running, but you can't actually get to it, which is really frustrating and really annoying. So I highly recommend before you take your snapshot of your servers that you go through that step on each of the Windows servers. It will just make life a lot easier, because otherwise what you'll have is you'll be in this situation where you're working with multiple servers and one of them will have shut off the screen, and sometimes you're able to just click into it and get back into it. But other times you keep clicking and nothing happens, and it's basically in a coma state and you have to reboot the server to get back into it. So just one of those words of wisdom that will save you guys some headaches. Just do that step after you get it all configured before you take your snapshot. It just makes life easier interacting with the virtual machines. Any questions before we go? Covered a lot. Okay, so I'm going to cut you loose. Again, if you have questions on the labs, make sure you're using password 01 for your Windows servers so that you can ping me with a question. Ideally, send a screenshot and say, I'm in this lab with this problem, or I'm stuck at this step in this lab, with a screenshot, because that gives me a fighting chance of making sure I know where you're at. Then I will most likely log into your virtual environment, take a look at your servers, and then be able to figure out where you're stuck. And then I will send you information about how to get unstuck. So that is one that I fully expect you guys to run into issues. The lab documents are purposely designed that they have about 80% of the information you need, not 100%. So you're going to want to be leveraging your resources. I'm trying to make this a lot more like it would be out in business, where your boss says, build me a SQL server. And you have some basic instructions on the web, but you don't have a cookbook. And so what you have to do is interpret a tech document for the environment you have and make it so that it does what you want it to do. So we're sort of graduating out of the A to Z cookbook of how to do things, and we're getting you ready to launch out into industry. And so I'm trying to get you more seasoned in this is how your resources are going to look when you're trying to do things in industry, and also bringing the pace up of how much you need to accomplish, because we're still probably at about a quarter of what you would do in a normal workday out in industry as far as pace, but we're ramping up, sort of that hockey stick model I had. We're starting to get pretty steep on the hockey stick for this particular section. But it's also cool stuff, and it's going to really come in handy when you get out there in industry, because if you do any sort of systems administration work, you're going to be building some SQL servers along the way, and understanding how they work and just the basics to secure them, configure them, set them up. It's really handy to know. But otherwise, I will call it a night, and I will see you guys next week.